Welcome back to QuantumX. In this series, we follow a middle-aged man building a log cabin by hand in the Alaskan wilderness, a place where harsh conditions leave no room for construction mistakes. This project is not viewed as inspiration, but as a real-world build, analyzed through structure, materials, and execution. From log selection and shrinkage control to joint design, snow load resistance, and frozen ground movement. By watching through to the end, viewers will understand why some cabins survive decades in extreme cold, while others fail after just a few winters. You'll see the right technical decisions and the risks that are often overlooked. Stay with us until the end to see the full process, step by step, with nothing important left out. The foundation had been prepared earlier, but as construction resumed, the entire site was buried under snow. Before moving forward, he had to clear it, not only to expose the base, but to check for any movement caused by freezing conditions. In Alaska, a foundation supports more than just the structure above. It must also accommodate ground movement from frozen soil. Even minor shifts can translate into twisting or failure in the log walls. Once stability was confirmed, he began installing the first log courses to form the walls. Each log was placed in a calculated sequence, ensuring precise joint engagement while allowing space for natural shrinkage as temperature and moisture levels change. Between each log courses, a continuous gasket is installed before stacking. This is not a secondary detail. It is the first line of defense against cold air infiltration, heat loss, and moisture intrusion. In Alaskan conditions, logs constantly expand and contract with temperature and humidity changes. Without a gasket, microscopic gaps form after only a few freeze cycles. The damage isn't immediate, but it accumulates season after season. The gasket allows controlled movement between logs while maintaining an airtight wall system. It reduces direct friction, limits joint cracking, and significantly improves overall thermal performance. In cold region cabins built to last, it's small technical decisions like this that define long-term durability. Once the wall reaches the required height for a door opening, he pauses the stacking process and begins cutting the logs. The logs are not cut earlier, as the wall needs sufficient weight to remain stable during construction. Cutting the opening at this stage allows precise control over height, vertical alignment, and load transfer around the opening. If done out of sequence, log shrinkage can cause doors to bind or frames to deform over subsequent winters. The cuts are made cleanly, leaving continuous log courses above to accommodate a future slip frame system. This design allows the log walls to settle and move independently, while the door opening remains dimensionally stable. In cold climate log construction, cutting an opening is not just removing wood, it's about managing structural movement. Once the wall system reaches its full height, the next step is installing the roof purlins. The rafter spacing and cross-section are calculated based on the heavy snow load, not only static weight, but also the accumulated force over several months. Each rafter is directly connected to the wall system using mortise and tenon joints and mechanical pins, allowing the load to be transferred vertically down to the foundation instead of pushing the force outwards. In extremely low temperatures, this connection must be both strong and capable of compensating for material expansion and contraction. The roof is designed with two different slopes instead of the traditional single symmetrical roof surface. The higher slope is raised to create space for skylights, allowing natural light to penetrate deep into the building during the short winter days. Technically, the steeper slope helps snow slide off faster, reducing the load accumulated on the purlins above. The space under the high roof slope expands the area below, which is used as a living room. This layout allows for increased usable volume without increasing foundation area, while keeping the roof load evenly distributed down the log walls. In Alaskan conditions, roof design is more than just aesthetics. It's about balancing light, snow load, and living space. On the porch floor framing, a waterproof flashing tape is applied before any decking boards are installed. It's a small step, but one that has a major impact on the long-term durability of the porch structure. In the main floor framing system, protection is taken a step further. After applying a waterproof adhesive layer, the framing is covered with metal flashing panels. This creates two independent layers of defense. The adhesive blocks direct moisture intrusion into the wood, while the metal sheeting provides mechanical protection against water, ice, and impact. At critical joints and edges, where water tends to collect and freeze, the metal helps shed moisture outward instead of trapping it within the structure. Once all protective layers beneath are complete, the final wood decking is installed to finish the porch floor. The porch floor is fully exposed to the environment, rain, ice, snow, and daily foot traffic. When this final layer is done correctly, it protects the entire system below while maintaining safety and stability over years of use. Next, he begins assembling the beams and rafters for the porch roof. While not part of the main structure, the porch roof is one of the most exposed elements of the cabin. The porch beams are securely tied into the log wall system and supported by front posts, ensuring loads are transferred vertically to the ground without pulling laterally on the main walls. Rafter spacing is calculated to handle localized snow accumulation and ice buildup, which often concentrates along roof edges. The porch roof pitch is set steep enough to shed water and snow, while maintaining usable headroom below. All connections are detailed to prevent water from backing into the wood, a common cause of early porch failure. After the weather membrane is fully sealed, he installs battens across both the porch roof and the main roof. This is a critical intermediate layer, often overlooked in small-scale builds. The battens create a ventilated cavity between the roofing material and the surface below, allowing moisture to escape rather than becoming trapped within the structure. In cold climates, this significantly reduces condensation and limits ice formation from the inside. Batten spacing and orientation are matched to the roofing material above, while evenly distributing snow loads down to the rafter system. Installing them consistently across both roof sections ensures the system performs as one, without weak points at transitions. In cold region cabins, battens are not just a fixing surface. They define how well the roof can breathe and how long it will last. After trimming excess wood from the roof structure and the tops of the log walls, the building's form becomes clearly defined. Squaring and cleaning these edges is not just about appearance, it ensures proper contact for the roofing layers above. With the surface prepared, he begins installing the metal roofing. In Alaska, metal is chosen for its ability to shed snow efficiently, its lightweight nature, and its durability through long freeze cycles. The panels are installed from the bottom up, with controlled overlaps to prevent water and ice from backing underneath. Fasteners are tightened securely while still allowing for thermal expansion, preventing warping or fastener failure over time. With the porch structure complete, he moves on to building the exterior wooden stairs leading up to the cabin. The process begins with measuring elevation carefully, ensuring each step has consistent rise and run for safe use in snow and icy conditions. The stair treads are cut precisely to calculated dimensions, with enough slope to shed water and reduce slipping risk. The wood is selected and treated to withstand moisture, freezing temperatures, and constant wear. Next, the porch railing system is installed. Posts and handrails are joined using traditional wood joinery, then reinforced with screws to ensure long-term stiffness and stability. This hybrid approach allows the wood structure to carry the primary loads, while mechanical fasteners control movement over time. In cold environments, where timber constantly expands and contracts, relying on a single connection method is rarely sufficient. Between the wooden posts, a cable railing system is tensioned precisely. Stainless steel cables provide safety without blocking the view, while significantly reducing maintenance compared to traditional wooden balusters. From an engineering standpoint, cable systems require even tension to prevent sagging and vibration, especially under temperature fluctuations. The result is a railing that is strong, visually clean, and well-suited for cold climate cabins where durability and low maintenance matter most. In the next step, he begins cutting window openings into the log walls. Vertical grooves are cut along both sides of the window opening to install steel anti-warp bars. These bars control bending and bowing of the log walls as moisture and temperature fluctuate throughout the seasons. Once the guide system is in place, a wooden buck frame is installed. This frame provides a solid anchoring surface for screws and hardware before the final window unit is mounted. It's a technical detail that determines whether windows continue to operate smoothly after years of harsh winters. The skylights above the roof are also fitted with fixed glass frames. Next, rigid foam insulation panels are installed on top to increase insulation and limit heat transfer through the roof. Finally, the metal roofing is constructed on top of the insulation layer to protect the structure and ensure the long-term durability of the building.
Next, he hired a professional well drilling team to establish an independent water supply for the cabin. The drilling process was carried out using specialized equipment, penetrating through layers of soil and rock until a water source with the required flow rate and quality was reached. Then, casing pipes were installed to reinforce the well walls, prevent subsidence, and limit contamination from the surface.
A submersible pump is lowered to the appropriate depth and connected to the main water line. To prevent freezing, the supply pipe is buried underground and wrapped in an insulation layer, keeping it below the frost line, where temperatures remain stable. In extreme cold climates, exposed or poorly insulated water lines can freeze within hours, leading to system failure. By insulating and burying the pipe correctly, the water supply remains functional year-round, even during prolonged sub-zero conditions. Above the water line coming from the well, he builds a small utility shed to house the radiant floor heating system. Placing the equipment directly over the buried supply line reduces heat loss and helps protect critical components from freezing. The shed provides a controlled environment for the boiler, circulation pumps, and manifolds, allowing the system to operate efficiently in extreme cold. In off-grid conditions, centralizing heating infrastructure like this simplifies maintenance while improving overall system reliability.
He began installing the underfloor heating system by using a specialized tool to secure the PEX pipes directly to the floor surface. Then a special mortar was spread evenly across the floor. This wasn't ordinary mortar or concrete, but a self-leveling, highly thermally conductive mortar specifically designed for underfloor heating systems. The mortar flowed smoothly, completely enveloping the heating pipes, eliminating any air voids. Once cured, this layer became a thermal reservoir, absorbing heat from the hot water in the PEX pipes and radiating it slowly and evenly into the space above. Fiberglass insulation is installed across the roof structure to reduce heat loss through the cabin's highest surface. The material is laid between the rafters, creating a continuous thermal barrier that slows heat transfer in both winter and summer. Fiberglass is chosen for its stable thermal performance, fire resistance, and ability to maintain insulation value in cold, dry conditions. Before installing the rigid foam insulation on the roof, the entire surface is sealed with a polyethylene plastic membrane. This layer acts as a vapor barrier, preventing warm, moisture-laden air from the interior from migrating into the roof assembly. In cold climates, uncontrolled moisture can condense inside insulation layers, reducing thermal performance and causing long-term structural damage. By sealing the roof with plastic sheeting first, the insulation remains dry and effective, ensuring the roof system performs as designed under extreme temperature differences.
Next, he installs a solid timber post inside the cabin, serving both as a structural support and a functional room divider. The post helps transfer roof and upper loads directly down to the floor system, reducing stress on the log walls. At the same time, it subtly defines separate living zones without enclosing the space with full-height walls. This approach maintains an open interior layout while preserving structural efficiency, an important balance in compact log cabin design.
Next, dimensional lumber is assembled into interior wall frames. These framed walls are non-load-bearing, designed to define interior rooms without interfering with the primary log structure. The framing allows for straight, level surfaces needed to install insulation, wiring, and interior finishes. In log cabins, this method separates structural loads from interior partitions, reducing stress caused by log movement over time.
Next, he begins installing the plumbing system for the kitchen and bathroom, routing water supply and drain lines through the interior wall framing. Pipe runs are kept as short and direct as possible to reduce pressure loss and minimize freezing risk in extreme cold. All penetrations through floors and walls are carefully sealed to prevent heat loss and moisture intrusion. At the same time, electrical wiring is installed throughout the cabin. Circuits are planned separately for lighting, outlets, appliances, and heating equipment to balance electrical loads and improve safety. All wiring terminates at a central electrical panel, allowing for controlled distribution and easier troubleshooting.
At this stage, he focuses on commissioning the radiant floor heating system. Hot water is circulated through the embedded PEX tubing, turning the entire floor into a low-temperature heat emitter. Unlike forced air systems, radiant heating transfers energy primarily through thermal radiation and conduction, warming objects and occupants directly rather than heating the air first. The system operates at lower water temperatures, improving energy efficiency and reducing thermal stress on components. Heat is distributed evenly from the ground up, eliminating cold spots and maintaining a stable indoor climate. As the project moves into interior finishing, he begins cladding the walls and ceiling with thin, flat wooden boards. These boards create a continuous interior surface while allowing the log structure behind them to move independently. The lightweight cladding is installed with controlled spacing to accommodate seasonal expansion and contraction of the wood. Beyond aesthetics, the wood lining adds an additional insulating layer and helps regulate indoor humidity by absorbing and releasing moisture naturally. In a log cabin, this finishing method balances durability, thermal performance, and visual warmth without adding unnecessary structural load.
He then begins installing the wooden flooring across the interior space. The boards are laid with precise spacing to allow for natural expansion caused by temperature changes and radiant floor heating below. Each plank is carefully aligned and secured to maintain a flat, stable surface over the heated subfloor. Wood is selected not only for its durability, but also for its compatibility with radiant heating systems, allowing heat to pass through efficiently without trapping moisture. In cold climates, proper flooring installation is critical.
In the kitchen area, he designs a pebble-stone wall backsplash with softly curved cut lines that bring a sense of flow and balance to the space. The organic shapes contrast with the straight lines of the wooden interior, adding visual softness without disrupting the cabin's structural character. Each stone is carefully set to ensure proper bonding and consistent spacing. Once the stones are in place, white grout or a specialized white adhesive is applied to fill the joints. The light-colored grout enhances the natural texture of the stones, while improving moisture resistance and ease of cleaning. In a working kitchen, this finish combines durability, low maintenance, and a refined natural aesthetic, well suited to a log cabin environment. He then installs the kitchen cabinets, carefully leveling each unit to ensure long-term stability on the wooden floor. Precise alignment is critical, especially in a log cabin where minor structural movement can occur over time. Once the cabinets are secured, the countertop is measured and drilled to accommodate the sink and faucet. Cutouts are made with tight tolerances to prevent water infiltration and protect the surrounding wood surfaces. The sink and faucet are then installed and connected to the previously routed plumbing lines. All joints are sealed and tested for leaks before final use. In an off-grid environment, reliable kitchen plumbing is essential, making accuracy and durability key priorities at this stage. Above the countertop, an open shelving system is installed, anchored to the wall using round steel rods. The steel supports transfer the load directly into the wall structure, allowing the shelves to remain visually light while maintaining strength. Solid wood boards are used for the shelf surfaces, chosen for their durability and compatibility with the cabin's interior finishes. This open design improves accessibility and airflow while reducing visual clutter in a compact space. In a log cabin, combining steel and wood like this balances structural reliability with a clean, modern aesthetic, requiring minimal maintenance over time. With the wardrobe completed and window curtains installed, the cabin reaches its final stage. What began as raw logs in a harsh Alaskan landscape has become a fully functional, off-grid living space. Every system, from structure and insulation to heating, water, and interior finishes, was built with long-term durability and efficiency in mind. This project is not just about shelter, but about understanding materials, climate, and construction logic in extreme conditions. If you found value in this build, take a moment to like the video, leave a comment, and share your thoughts. Your feedback helps shape future projects here on QuantumX. And if you want to follow more real-world builds like this, make sure to subscribe and watch until the end. Thank you for watching.